Assalamualaikum. Today we discuss about this heat and mass transfer problem. It's very big problem. Please give me your full concentration. I try to finish within short time. Let's start. Steam is the 1 infinity, the T infinity first, and also pipe conductivity. Also thermal conductivity has given, and another is the whole inner and outer diameter has given, and respectively pipe covered with very crucial part, pipe covered with 3 semi, and thickness glass wool insulator with, that means glass in this insulation thermal conductivity, and also heat loss surrounding in T infinity to 5 degree Celsius, and also with conductivity transfer coefficient is given, and taking the heat transfer coefficient also is given, and determine the rate of heat. We have to determine the rate of heat, and also the steam per, we have to calculate the per unit of length, L equal to 1. Okay, pipe also determine the temperature drop. Also we have to remember, we have to find out the temperature dropped across the pipe and insulation. This is the crucial point. Also this one is the pipe, here is D and D1, this one is D1 and this one D2, and here the covered with insulation. Insulation is also 3 semi is given, and this pipe, this one, if we consider that, and also heat is coming from end radiation T infinity 1 and T infinity 2. If we draw this resistance, and this one is the for convection or convection 1, and is our conductance in pipe materials, and also this one is the conductance for insulation, and another also is the R convection 2. Okay, infinity 2 and T infinity 1 is the total resistance. Okay, you keep in mind convection all are plus, it's 4 plus, and also here a T1 and T2 and T3. Okay, and another is 1 is the 60, okay, no need meter square Kelvin, and another is the is 2 18 watt per meter square Kelvin. In diameter we have to diameter D1 is the 5 semi and 0.05 meter, and D2 5.5 semi, that means 0.055 meter, and here R1 radius is the 0.025 meter, and R2 is the also R2. Here R2 is also 2.75 meter. Okay, another one, the R3 is very crucial point. R3, which one is R3? Here R3 is R3 in insulation. Insulation is total point, so we have to divide this total diameter, that means D2 divided by 2 plus 3. That means D2 is 5.5 semi divided by 2 plus 3. That means 5.75 semi. Okay, that's the R3 is semi, because this one we have needed. Okay, and also another is the we have to find out heat rate. We have to find out and pipe temperature loss, drop pipe, and also we have to find out the temperature insulation. Okay, so we know Q rate equal to del T divided by R total. Del T equal to here is infinity 1 minus T infinity 2 divided by R total. We know alpha 1 is equal to 320 minus 5, T1 and 5, but we don't know this total. We have to find out this total. Okay, that's why we have to find out the del Q rate mass heat rate equal to, we have to find out the RT, R total, and also we have seen 320 minus 5, but we have to find out this R total equal to, for conduction AC and for convection. For conduction is the for circular ln equal to R2 divided by R1 divided by 2 pi KL. This is the formula K1L, and also ln R3 divided by R2 divided by 2 pi K 2L plus 1 by and R2A. Okay, so we have to find out this A and this A, because all value we know, we have known, but we don't know the A1 and A2. And A1 equal to 2 pi RL. This one is a periphery area. That's 2 pi R1L. That means 2 pi R1, we know 0.025 into 1 equal to 0.157 meters square. Okay, and A2 equal to 2 pi R2L. This means 2 pi, and R2 is the 0.0575 into 1 equal to 0.361 meters square. And by this we will get this 1 divided by S1. We have seen before S1 in previous slide. S1 we know 60, S2 in S1 is 60, and A1 is the 0.157 plus RL ln means ln R2. What was R2? R2 is the 2.75 divided by R1 2.5 and 2 pi K1. K1 is 80 into 1, and also ln 5.75 divided by 2.75 divided by 2 pi K2 is here, and K2 0.05 into 1, and also H2 18 into 0.361 and R2 equal to, and after calculating R total will get and 2.61 degree per watt. And after total resistance we'll put an 315 divided by 2.61, then we'll get our desirable heat rate is 121 watt answer. Also another two answer left. We know Q heat rate equal to del T for pipe divided by R pipe. Okay, and from this del T pipe we know and heat rate into R resistance of pipe. After putting 121 into 0.002 and then we'll get 0.02 degrees Celsius. Another del T for insulation Q rate of heat into R insulation. That means 121 into 2.35. This means 284 degrees Celsius. That one and that one are also answer. Thanks for watching. I think it's clear to you. Though if you have any confusion, you can write them in comment section. Thank you.